Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 1, Lesson 5, Types of Angles and Their Relationships. Straight angle, you might recognize this. We've actually already talked about straight angle. A straight angle, remember, basically looks like a line. So maybe like this, where you have 3 points. Perhaps it is A, B, and C. And this angle right here, angle ABC, is a straight angle. A straight angle measures 180 degrees. Next, we have adjacent angles. Adjacent angles are angles that are right next to each other. They share a vertex and a side. So remember, a vertex is like the corner or the point of an angle. So adjacent angles look like this. Maybe this is angle 1 and this is angle 2. Notice they have a common vertex. Here it is. That's the vertex for angle 1 and 2. And they also have a common side, and that's right here in between them, that ray right there. So these would be adjacent angles. Angle 1 and angle 2. They're right next to each other. Next we have linear pair. Notice the word linear has the word line in it. So that's what I think of. I just think of, okay, I have a line, and then I break it into a pair of angles. So for instance here, angle 1 and 2, this angle plus this angle would make a linear pair. Together, they form 180 degrees, and notice they are adjacent to each other. And next we have vertical angles. Vertical angles are 2 angles that are not right next to each other, and they're formed by lines that intersect. So for instance, if I number these off, 1, 2, 3, and 4, 1 and 3 are a pair of vertical angles, and their measures are equal. So angles 1 and 3 would have the same measure. Same thing with angles 2 and 4. Those will have the same measure. So angle 1 and angle 3 are a pair of vertical angles, and then angle 2 and angle 4 are another pair of vertical angles. They're across from each other in an X, basically. Lots of vocab today. Next, we're going to talk about complementary angles. Complementary angles are 2 angles that, when added together, make 90 degrees. So one way that might look is you might have a pair of adjacent angles like this. Angle 1 and 2 are complementary because together they would add up to 90 degrees. Or you might have a pair of non-adjacent angles. For instance, this angle might be 30 and this angle might be 60. And together they are complementary to each other, but they are not adjacent angles. They're non-adjacent angles. Supplementary angles are 2 angles that, when added together, form a 180 degree angle, or they add up to 180. One way that might look is you might have a linear pair. So these 2 angles right here, angle 1 and angle 2, they would be supplementary to each other because they would add up to 180. Another way that you might have a pair of supplementary angles is you might have one angle that's, say, 30 degrees, and then another angle that is perhaps 150 degrees. So together they add up to 180, and again, they would be supplementary. And then finally, we have perpendicular lines. 2 lines that, when they meet, form a 90 degree angle. Perpendicular lines look like this. They cross at 90 degrees. The symbol for perpendicular, this is important. You're going to see this sometimes. The symbol is an upside down T. So I could say, like, this is line M and this is line N. And the way that I could write that is I could write M is perpendicular to N with that upside down T. At this point, please pause the video and try numbers 1 and 2. After you've tried them, go ahead and unpause. There are many linear pairs in this picture. Remember, a linear pair is when you have a line that is divided into a pair of angles. So for instance, here and here, these 2 would make a linear pair. That would be angle UVQ and angle QVR. I'll show you another set that would work. Let me show you another example. Here's a line, and let's divide it into a pair of angles. So we're going to go here and here. So this would be another example, and this would be angle, we could say QVR, that's this top one up here, and then angle RVT. That's this bottom one down here. So basically you have to find somewhere where you are dividing it into two angles that would make a linear pair. Number 2, name a pair of acute vertical angles. So remember vertical, it's like when you have an X and they're across from each other. So maybe a good spot would be like if I make an X like this, for instance. Now we need to pick the two angles that are across from each other that look like they're acute. So I was thinking like here and here. Those are vertical angles to each other. They're across from each other in the X, and they do look like they're less than 90 degrees. So we would name that angle PVU and angle SVR. So remember, if you're not sure how to name an angle, just start at one spot, trace it, right? So here we started at S, we went to V, we went to R. That'd be a good way to name that angle. You could have also named it RVS. Another pair that would probably work for acute vertical angles are these two green ones. So we could have also said angle UVT and angle QVR. Those look like they're acute to me, and they are definitely vertical angles. Please pause the video, try numbers 3, 4, and 5. These are all true and false. All right, angle YZT. So if I trace from Y to Z to T, we are trying to figure out, is that 90 degrees? I would say it is true because right here we have a 90 degrees and this is a straight line. So this would also have to be 90 degrees so that they add up to 180. 180 minus 90 is 90. So I would say that is true. Number 4, angle TZX. Let's trace that here. TZX. And angle TZU, so TZU, are supplementary. Again, take a look at them. Here's the first angle, here's the second angle. To me, those look like a linear pair. We have a straight line right here, so they should add up to be 180. Supplementary means they add up to 180, so I believe this is true. Number 5, true or false? Angle YZX, so if I trace that, YZX is this angle over here, and angle TZS, so TZS, that's this angle right over here. Are they adjacent angles? Well, it is true that they have a common vertex right here. They have to have the same vertex, but they're also supposed to share a side, and these do not share a side. Angle TZS has this side, and there's a space here before we reach the other angle, and so they do not have a common side, so this would be false. All right, let's see about your translation skills. Go ahead, pause the video, try numbers 6, 7, 8, 9, and 10. You're translating these phrases from English into algebra. So see if you can write it like an algebraic expression. Number 6, 5 more than a number. So I did x plus 5. That would be 5 more than some number. Number 7, 6 less than a number. So I did some number, take away 6. This would be 6 less than that number. 4 times a number, 4x. And really you can use any letter. Maybe some of you used n for number. That's okay. Next one, 2 less than 3 times a number. So first of all, I'm thinking about 3 times a number. That would be 3x. And now I need 2 less than that. So I'm going to take away 2. That is 2 less than 3 times a number. Number 10. 10 longer than twice the length. Do twice the length first. So that'd be 2 times some number. And then 10 longer than that. So there we have 10 longer than twice the length. And again, you might have used L for length, and that is great. For number 11, we're going to take those algebraic skills, that translation skill, and we're going to apply it to a geometry question. So number 11 says, find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other. I see I have two angles, and I see that they're supplementary. Now remember, supplementary means they add up to 180 degrees. So I'm going to have something plus something add up to 180 because they have to be supplementary. I don't really know what either angle is. So what I'm going to do is I'm going to call the first angle X, but then the other angle has to be 6 less than 5 times that measure. 6 less than 5 times that measure. So I'm going to say 5x, and then I have to do 6 less than that. That would be minus 6. So that is 6 less than 5 times the first angle. There you have it. That's your equation. Now you need to solve this. And so you're going to add your like terms. You have 1x and 5x. That's going to make 6x minus 6 equal 180. Add your 6 to both sides. So then you have 6x equals 186. Divide by 6. If you need to grab your calculator, go right ahead. 18 goes in, or 6 goes into 18 3 times, 6 goes into 6 once. So I think it's 31. But we're still not quite done. It says find the measures of the two supplementary angles. So we know one angle is 31 degrees, but we have to find its supplement. And so there's a couple ways you could do it. First, you could plug the 31 in up here and do 5 times 31 minus 6. Or because they're supplements, you could also just take 180 minus 31 to get your other angle. I believe that comes out to be 149 degrees. And so the two angles would be 31 degrees and 149 degrees. Let's try another one of those. They're pretty tricky. So number 12. Find the measure of two supplementary angles if the difference in the measure of the two angles is 18. I see that word supplementary again, and I know it means 180 degrees. So I'm going to have two angles that add up to 180. I have no idea what either angle is, so I'll call the first one X. But then this one says the difference in the measures of the two angles is 18. Now, when I see the word difference, I usually think subtract. And so I think the other angle is going to be X minus 18. That one's going to have a difference of 18 from the first one. Combine your like terms. X plus X is 2X. 2X minus 18 equals 180. Now I'm going to add 18, bring it to the other side, add that constant. So we wind up with 2X equals 198. Divide by 2, X equals 99. So one of the angles is 99 degrees. You got a couple of options. You could plug it in up here to find the other angle, or what you know is that they're supplementary, so you could also do 180 minus 99 to get the second one, which is 81 degrees, and then they add up to 180 as well. Number 13, an angle's measure is 8 more than the measure of the complement to it. Find the measures of the angle and its complement. All right, think about complement. That's like complementary. So complements add up to 90 degrees. So in this case, we have two angles and their complements. So I'm going to have something plus something equals 90. I don't know what either angle is. I call the first one X. The second one has to be 8 more than the complement. So I'm going to have X plus 8. That one would be 8 more than the first one. Start simplifying. X plus X is 2X minus your 8. So what is that? 82. Divide by 2, and X equals 41 degrees. That's one of the angles. To find the other one, you could either take that 41 and plug it in right here, or you can take 90 minus the 41 because they have to be complements, and this turns out to be 49 degrees. So there's the two angles. One of them is 8 more than the other, and they are complements because they add up to 90. Many of the homework questions on tonight's homework will be like this last example. It says find x and y if line KO and line HM are perpendicular. You guys, let's find KO, that's here, and HM, that's here. And it says they're perpendicular. That means they're going to meet at 90 degrees. Then it says this, the measure of angle MJO is 3y plus 6. That's right here, angle MJO, over there on the right. And the measure of angle KJI, so if I trace from K to J to I, that's like this little guy right here. That one is 3x plus 6. And finally, the measure of angle IJH is 9x. Now, if I trace from I to J to H, that's right in there, and that's 9x. And we're supposed to try to find x and y. Well, I kind of think this is two separate questions, one for finding x and one for finding y. It really doesn't matter which one we do first. I guess I'll do x first because it's alphabetical. Now I notice that over here are the x's, the 3x plus 6 and the 9x. Notice how, if I look at that blue x that is drawn in, I have a 90 degree over here on the right, and vertically across from it should also be another 90 degree angle. Vertical angles would have the same size. So here's what I'm thinking. The 3x plus 6 added to the 9x should equal 90 degrees. These two angles together should equal 90 degrees. And I kind of drew over it, but remember this over here was 9x. So add those together equal 90. Okay, so to solve, I have 3x and 9x, that's 12x plus 6 equals 90. Subtract your 6, 12x equals 84, divide by 12, and x equals, I think it's 7. You might want to check that on your calculator just to be sure. But there we have part of our solution. We have solved for x. Now we also need to solve for y. And so y is in its own little spot over here on the right, and notice it also has a 90 degree angle mark. So I think to find y, we're just going to say 3y plus 6 equals 90 as well, because it's a 90 degree angle there. The lines were perpendicular. So subtract your 6, you're going to get 3y equals 84, divide by 3, and y equals 28. Again, you can check that with your calculator and see if it's really 28. Again, you're going to run into some of these on your homework. Do your best. Think about, like, how big are those angles? Are they equal to each other? Should they add up to 180? Should they add up to 90? Things like that. And make an equation and then try to solve the equation. So that's it for today. Good luck on Unit 1, Practice 5. If you have questions, please don't hesitate to send me a Schoology message and I'll get back to you. Have a great day.